Today we're going to be working on Leetcode question number 297, serialize and deserialize a binary tree. Okay, serialization is the process of converting a data structure or object into a sequence of bits so that it can be stored in a file or memory buffer or transmitted across a network connection linked to be restructured later in the same or another computer environment. Okay, we're going to be designing an algorithm to serialize and deserialize a binary tree. There is no restriction on how your serialization deserialization algorithm should work. You just need to ensure that the binary tree can be serialized to a string. Okay, it's going to be a binary tree and it can be serialized to a string, and this string can be deserialized in the original tree structure. Okay, so we're just going to be when we're going to be serializing, we're going to be putting this format of like representation of the tree node into string, and then we're going to take, when we say the deserialize, we're going to be taking that string and putting it into the, like converting it back to the tree structure. For this one, what we're going to be doing is we're going to be making use of two things. One is like for the representation of a null, we're gonna be using uh, public final string n, basically meaning that the null node, we're gonna be representing it as n, and another variable we need is we're gonna call it a splitter, which is basically gonna be another name of a comma, because we're gonna be putting, just like over here, all the nodes are separated by a comma. So we wanna be, when we are creating the string, we're gonna be like separating all the nodes with a comma. So we're gonna just name it splitter. Okay, that being said, in serialize, what we're gonna be doing is basically we're gonna have a string builder. uh, yes. Okay, we're gonna have a string builder, and then we're gonna use a helper function called build string, and we're gonna be pushing this sb, our string builder, and the root of the binary tree, and then it's gonna do the magic, and it's gonna be able to give us this sb. So we're just gonna be returning, like, all the information is gonna be serialized to a string in the sb. So we're gonna be returning sb dot to string, as it was a string builder. In order to get the string out of it, we're gonna be using this function show to string. Okay, now what exactly is this uh, function gonna do? So basically it's not returning anything, but it is putting everything inside that sb, which is a string builder sb, and it takes the tree node root. So again, the basic logic is that if you see that the root is equal to null, right, if that is the case, you know that you're going to be appending uh, some representation of null, which we're going to be saying that this is the n, and then append the splitter. So we are saying that if you see a null, append n and a comma at the end. Okay, and then you can just return. Because we just have to, whatever we do, we have to do the reverse of it in order to deserialize it. So it's okay if we have a comma at the end, uh, and like even if there is a comma at the end, we're just gonna be like, our logic is still gonna work. Okay, and once you do that, otherwise, if that is not the case, if the root is not null, we're gonna recursively call our function. But first, we're gonna say sb dot append root dot value dot append that splitter. Okay, and after that recursively call this build string. One time we're gonna be doing sp dot root dot left. The other time we're gonna say build string sp root dot right. So we're gonna be calling the same function for our left node and the right node. Okay, now the last thing we need to do is the deserialize. For the deserializing, we're gonna be using a queue of string, right? Uh, which is gonna be equal to new linked list. Okay, and then we're gonna add. So basically, we have been given this string, right? So what we're gonna be doing is like split it first with the splitter, like with the comma, and then we're gonna say convert, take it as arrays as list. Okay, and put all of it into the queue. Okay, yes, so put all of it into our queue, and then we're gonna use a helper function called build. Let's call it build tree, and we're gonna be pushing this queue, like we're gonna be sending this queue to this helper function. So for this helper function, this does return a tree node, right? That's what we want to return in the end. It is called build tree. It takes a queue, which is basically, okay, yeah, it's a linked list, but it is taking a queue. Okay, okay, for this one we're gonna say that, okay, we're gonna create our string which is equal to current. We're gonna say that q dot remove, so that we're gonna remove the first element from the queue and start with that string, right? Now if that the element which is removed from the queue, if that current is basically equals our representation of a null, in that case we're just gonna return null, right? Otherwise we're gonna be creating the tree node n is gonna be equal to new tree node with the value of this string, like the current string, and then we're gonna say our left is gonna be equal to, we're gonna recursively call this build tree and the same queue, because we already removed the first element and we're sending the rest of it. And then for the right we're gonna say build tree and then queue, and then we're gonna be returning n. string append. Cannot find the symbol n. It is null node is n. Looking good. And it works.